So welcome everybody to this latest A2 video on 162 Maths, and in this video we're continuing with series and sequences and geometric progression, but focusing on the sum to infinity. So in a geometric progression, if the common ratio is between -1 and 1, and as n tends towards infinity, then the value of un either converges to a particular value. So for example, if we take the geometric series where a is 16 and r equals 0.5. So what we're doing is we're starting with 16 and we are going to multiply it by a common ratio of 0.5, which is technically halving it, and end up with 8, then 4, then 2, then 1, then 0.5, then 0.25, then 0.125. So what you could say is that for this, that as n tends towards or gets bigger, the position gets bigger as I go further along in the series, that un will eventually become 0. Now if I then took the negative value of r equaling minus 0.5 or minus a half, then again I'm starting with 16, but all that happens is that the sign of the term will basically oscillate, so it'll turn negative, positive, positive, negative, etc. So here I'll have -2, then 1, then minus 0.5, then positive 0.25, then minus 0.125, and that will again continue, that as I go further along the sequence, even though the signs will sort of oscillate, it's going to tend towards, so if that goes to infinity, then un will eventually become 0. So whereas this, if you imagine like a graph with n being along the side and un being along the y-axis, it's going to end up being something that looks like this. With the second sequence, what's that going to look like? Well, for starters, the axis isn't going to look like that. The axis, if I made it look like this, will basically start at 16, then it goes to -8, then it goes to 4, and eventually it will sort of peter off to 0, and that's the un, and that there is n. So eventually it will tend towards 0. So as knowing that n tends towards infinity and knowing that the value of un converges, it would then therefore be possible to work out all the sums in the entire GP. So for example, what we call this is the sum to infinity, where you add up every single possible term in there, because eventually the last term is going to end up being 0 or a particular number. So if we look at the sum of n equals a 1 minus r to the n over 1 minus r. Now as n tends towards infinity and r is a value that's between -1 and 1, what you notice is that the digits are actually going to get smaller. So what happens then is that this number, as n tends towards infinity and r is a number that's basically going to be, or a ratio that's constantly decreasing, that r to the power of n is also going to tend towards 0. Now if that then becomes 0, then what have I got left? Well, that therefore means that the sum to infinity is simply just going to be 1a over 1 minus r. So here is the formula for us to put into our notes. So in a geometric series, when r is between -1 and 1, then it is possible for you to work out the sum to infinity, which is basically the sum of all the terms in a particular sequence. And this formula is given to you in your formula book, so it's not one you have to remember, but certainly one you do need to learn how to use. So let's have a look at our first example then. So the first question says, find the sum to infinity of the geometric series of 108, 36, 12 and 4. Now, as always, what we want to do first is find the values of a and r. We do this exactly the same way as we've done with finding the nth term and finding the sum of n terms. So here my a is 108, and if this value here is a, this value here is going to be AR, and taking those two numbers, so to work out R, that's going to be AR over A, which is 36 over 108, and if I go on to simplify that, I get R equals a third, which of course it is if I just took two smaller terms. So from this, what I can then do is then, for step 2, is then use the formula So the sum to infinity is a over 1 minus r. So substituting those numbers in, I get the sum to infinity equals, and it's going to be 108 over 1 minus a third. And if I just simply stick that into my calculator, I get an answer of 162. So let's have a look at our next example. So here it says find the common ratio of the geometric series which has the first term of 12 and a sum to infinity of 15. So let's just highlight some of the information that we know. So here we know that a equals 12 and the sum to infinity equals 15. So then using this sum to infinity equals 15 and not using yellow because that has not come out quite nicely, what we've got is we've got that 12 over 1 minus r equals 15. Now if I just put brackets around that, I can take that to the other side. So what I end up is with 12 equals 15, 1 minus r. So 12 equals 15 minus 15r. Take the 15 over to the other side, so I end up with minus 3 equals minus 15r. And so r equals minus 3 over minus 15, which equals 1/5. Now moving on to example 3, it says that a geometric series has the second term of 6 and the sum to infinity of 27. Find the possible values of the common ratio and the first term. So for this we know that the second term is 6. Now the second term written algebraically is AR, and we know that the sum to infinity is equal to 27. So let's have a look at what we can work with here. So we know that AR is 6. There's not much else I can do with that at this moment in time. So looking at this, the sum to infinity, we know that a over 1 minus r equals 27. Now from this I'm thinking, well, okay, let's see what we can do. Well, the only thing I can do with this is make a equal to 27 minus 27r. But what I can do is rearrange the AR equals 6 to give me a equals 6 over r. Now if I substitute those into, so sub that into here, what I end up with is 6 over r equals 27 minus 27r. And then if I multiply it, take the r over to the side, end up with 6 equals 27r minus 27r squared. And hopefully what you can now spot is that it's going to be a quadratic equation. So what I've then got is I've got 27r squared minus 27r plus 6 equals 0. I can divide everything by 3 just to make it a little bit easier. So here I end up with 9r squared minus 9r plus 2 equals 0. And then all I then need to do is then go on to solve this either by factorising or by using the formula or using my calculator, in which we get that r equals 2/3 or r equals 1/3. Now from this it's asked us to work out the possible values of r and a. So what we then need to do is we then need to say, well, when r equals 1/3, a is going to equal, now how I'm going to work that is I'm just going to substitute that into ar equals 6. So here I've got 6 divided by 1/3, which gives me 18. And when r equals 2/3, then a is going to equal 9. And there is my final answer. So moving on to our last example, it says that when a ball is dropped onto a hard surface, it always bounces to a height equal to 0.8 of the height of which it was dropped. The ball is initially dropped from a height of 2 meters. How far does the ball travel before it stops bouncing? Now the important thing with this question is that we're not calculating how many bounces of the ball it makes. What we're looking at is what's the total distance. So from this, if we imagine our distance, and here is the ball. So obviously the ball is going to bounce. So let's imagine that it's going to be bounced sort of across. So it's there, then it bounces to 80% of the other height, then 80% of that, 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 until it eventually stops. Now what this question is asking us is to basically work out the total length of that red line. So it's not how many bounces, therefore how many terms there are, it's basically the total sum to infinity. So what this question is asking me is the total sum to infinity. Now we know here that A is going to equal 2 and R is going to equal 0.8. So to find the sum to infinity, all we then need to do is use the formula. So it's going to be 2 divided by 1 minus 0.8, and typing that then in, we get 2 divided by 0.2, which gives me 10. So the answer is going to be 10 meters.